Hello everyone, in this video, I'm going to demonstrate how to work with Cassandra using Python. We will cover the following tasks. So in order to do the following task, we will go to the virtual machine, which is provided to us. And now we will be navigating to the week 4 folder where the file is located. So now I will execute code.command, which will open the VS code in our virtual machine. So in order to start the Cassandra, we will be opening the terminal. Now we'll list all the files which are present in this folder. So there's a Docker folder. We need to activate the Docker up. So we have to go to the Docker folder by using the command cd space Docker. Thereafter, we have to list out all the files which are there in the folder, and we will be opening the Cassandra multinode folder using the command cd. So again, we'll list out all the files which are present in the folder. So in order to make the Docker compose up, we have to execute doc command called docker co- compose up. So once we execute the command, now our Docker is running in the this environment, BD environment. We can observe that we are working on the BD environment here. So now when coming to the task, so we are done with the top two steps, and now we have connected to the Cassandra database as well. So now we will be importing the packages which are required to work on the Cassandra cluster. So we will be importing the required packages called pandas as well as cassandra.cluster from the and we'll be importing the cluster from cassandra.cluster. So thereafter we'll be creating a session for the cluster where the Cassandra database needs to be run. So we'll execute each and every part here. Now the files are successfully the libraries are successfully imported, and thereafter we are creating a session to connect to Cassandra cluster. And by writing this line like session.execute, now we'll be creating a key space called m14. So we are making sure whether m14 key space with the name m14 exists or not. If it is exists, we are dropping the present key space with the name m14. So it is checking whether the key space is present in the environment or not. If it is not if it is present, we'll be dropping the existing key space. So now there is in now we'll be creating a new key space with the name m14, and there is a replication factor with 2. 2 is the number of nodes in the ring like structure. So now we are done with creating a key space as well as connecting to the Cassandra database. So now we'll work on the create a table in this key space that will be used to store uh, inventory information. This include SKU, which is shown for stock keeping unit, name, short name for the product, and description, which is a text again, and warehouse number, the warehouse number where the product is stored. So now our main thing is to search for all products located at a given location. So we have to think about the database structure which we are going to create. So here it stated that if you created two rows with location 1 2 3, list all products at location 1 2 3. Here the location means warehouse, that is warehouse number. So here 1 2 3 can be duplicated, that means warehouse number can be duplicated, so warehouse number can't be primary key. So we will create SKU as a primary key in our upcoming data modeling. So after creating the key space, we'll be making sure whether our key space is created or not. So in order to make sure, we'll be executing the following line. So this will list out all the key spaces which are present in the present environment. So our m14 key space is created and it is listed out in this environment. So this means our key space is created. So now we'll be creating the table as per the task. So we named it as an inventory table. So here we are creating the table if it is not exist. This is the syntax of uh, Cassandra DB for creating the table. So here we will be creating the table if not exists m14 dot inventory. So SKU is a UUID here. So UUID stands for Universally Unique Identifier. It's a 128-bit identifier that is globally unique and is often used in computer systems to uniquely identify resources or entities. UUIDs are designed to be generated in a way that minimizes the likelihood of two different entities having the same UUID. And the other attribute is name with the data type text, description with the data type text, and warehouse number with the data type int, and will be considered SKU as a primary key as it is a UID. And thereafter, we have to populate the several rows of data into our inventory table. So what I'm doing is I have created a local static data, and I've created SKU and names and description and warehouse number for around 10 different rows of data. So I'll be executing this. We will collect the data into this data variable, and thereafter using pandas we will convert our data into the data frame, and we'll be displaying the data frame in below. So this is the data frame which got created. So now we have to insert all this data inside our inventory table. So using a for loop here, we have created using the session dot execute, we'll be inserting all the table all the data which is present in the above table into this inventory table. So when we execute the following line, all the tables from the data frame got inserted into the inventory table. In order to make sure whether it is inserted or not, we'll execute a following select query, which states that select SKU name, description, and warehouse number from m14.inventory. This is the way of executing query in Cassandra DB, and we'll collect all the data which is imported from the local variable into the table. And now we'll execute the following line, and this will collect all the data in the rows variable. So we'll print out all the variables which are present in the inventory table. So we made sure that the data which is imported previously got inserted successfully into the inventory table, and we are able to query it and fetch the all the 10 values which are already inserted. So now, uh, according to the requirement, we have to search for all products located at a given location. So now normally we can actually select the product names from the given location. Now I'm trying to filter the data, filter the product data which are present in the warehouse number one. So I have written the query called select name from m14 dot inventory where warehouse underscore num is equal to one. But when I try to execute this, I'll be receiving a following error. That's because so now the error you are encountering when performing filtering without using the allow filtering syntax in Cassandra is expected behavior. So Cassandra throws an error when you attempt to perform queries that involve filtering on non-indexed columns or non-primary keys. So here we are trying to filter the data uh, on the column warehouse underscore num, which is not a primary key, as well as it is not having any index. So if we try to do any kind of such operation on any non-primary key or non-indexed column, then we will face the following error. So in order to make it happen, we have allowed the filtering allow filtering syntax on this specific query. So when we execute this line, we'll be able to get the following product details. So we have successfully achieved the thing, but here there's a problem. Allowing filtering in Cassandra queries. So when working with Cassandra, you might need to allow filtering in your queries, but it enables filter or sorting on columns. But we have to be cautious as it has significant implications. So Cassandra scans the entire data set. It's called as full table scan. which is inefficient for large data sets. And there will be a performance issue as well as high CPU and memory usage may destabilize the Cassandra cluster. So this is not at all preferable according to the according to the Cassandra DB. So what we are doing is now we'll try to create an index, which is our another requirement in our following tasks. So we'll try to create an index in order to make it optimized. In order to make it as an optimized query, we'll try to create an index on warehouse underscore num. So now we'll create index if not exist warehouse underscore num underscore on m14.inventory warehouse underscore num. This is a query, and after executing this query, it will create an index on warehouse underscore num in inventory table. So now, even without using the allow filtering, also we will be easily able to fetch the data from the product data from the inventory table. So when you execute a query that filters or sorts by the indexed column, Cassandra can use the index to quickly locate the relevant rows. And also, instead of scanning the entire table, it looks up the values in the index and identifies the corresponding rows, and it returns the result just like this. And also, we have successfully completed all the tasks and working with Cassandra. You can now manage your inventory data efficiently. If you have any questions or need further assistance, please feel free to ask. Thank you for watching.